So we do know right off the bat that the correct answer for this area can't be any larger than 2, because we can embed the whole picture inside a rectangle of height 1 and width 2. Another thing you could do is probably realize that by symmetry, if you can find the area under the right-hand half of the figure, you can double it to get the area under the whole figure. And so, because from the picture you see this is an even function. So what's happening, I'm going to draw this in over here. What we've just been talking about is an idea several people had, which was to look at this and say that this is 0.5 and this is 0.5. And so the total area that we're trying to find is bigger than what's enclosed in blue, which is 1, and less than what's enclosed in red, which is 2. So you know you're trying to find a number between 1 and 2. And then the process that you were working on there, and different people did this part different ways. Some went through and found a point that was about like here, I guess would be better. And so now I can look at this triangle, which is 1, 2, 3, 4 tenths on the side. So it's 4 tenths times, that looks like 1, 2, 3, and, oh wait, that's just my not being careful in drawing. That's actually 4. So this is 0.16 over 2, so that's 0.08. And then go up and just start chopping the thing into smaller and smaller triangles. So over here, there'd be a similar picture, which would be 0.08. And so you could start adding up the areas of these different pieces. And that's very much in the spirit of the presentation in the book, which is done in terms of rectangles, but this being done with triangles. So there's another idea. Let me hand this right back to you and see if I can capture what you just said. Maybe like right there?
Well, or higher up, because you made the whole thing a rectangle.
Okay.
Given it 2 square units, or 2 units all the way across.
Okay, so right, I have enclosed it in a rectangle, which was 2 units across.
So if you made a tangent line from basically, where you're at, you can even go a little higher, you can do where you're at, just to get a right triangle, and then you could use your sine, cosine, or tangent for that.
So if I could approximate, so maybe a little bit higher and do something like this,
And just about knowing, because it was a 30, 60, 90, so you have.
We might have a hard time arguing that this was one of the special triangles of 30, 60, 90, but if we can approximate the height and the width of the triangle, we can get its area. And so I guess the idea here would be to take the total of 2 units, 2 square units, and then try to estimate the area on this. So if we did that, this is about 0.1, 0.2, 0.3, 0.4, about 0.45, and this is 1, 2, 3, 0.4, 0.5, 0.6. This is about 0.7. And so if I multiply 0.7 times 0.45, and so I get 7 times 5 is 35, and here I get 28, and 3 is 31, and it's 3 decimal places. And it'd be half of that, but by symmetry, I can do the same thing over here, a mirror image picture. And so basically, if I take 2 minus 0.315, then the only thing I've got that's really not accounted for
So it's 4 small slivers.
is these little slivers right here.
So it just brings it closer.
And so I get a little bit closer there, and then I might be able to go through and do something similar. So 2 minus 0.315, that would be about 1.685. So you still haven't hit on how a sixth grader would do it, because they probably don't know the formula for the area of a triangle, but
That just counts squares.
that was something did anybody actually do that? Count squares? Okay, so how do you have a picture of it that represents the So what Adam's pointing at there is coming across here, and about how far did you go?
3.
About 3?
12.3, I guess.
Okay, so about 3/10 of a unit, and then you can multiply to figure out what all this is.
Yeah, and then so you go around the curve, and anytime, the first time you do it, you can count the blocks, even if the line goes through the middle of the block, count that block, and then the second time, don't count that block, and then average it.
Okay, so basically here, you would count all of these because they're entirely in, and then you go through, and if your rule was, if any of the block is under the curve, you count it, then you would count this one, this one, this one, this one, this one. All of these entire blocks get counted, and so you just add them up. So you're getting basically a picture that includes all of these blocks. You'd include that one, and that one is kind of hard to tell. It's mostly under, I guess you would include it, you would include that one. So you get a lot of overage there because you're counting anything that has even a little bit of it underneath, and that's going to give you an overestimate of the entire thing. Then if you went through and said, well, if we do the same process, but now if any of it's outside of the curve, we don't count it at all. So you get this, maybe that one, but then this one you wouldn't count, and you wouldn't count that one, and you wouldn't count that one either. And so you're going to get a fairly substantial underestimate, because if any part of the block is outside the curve, it doesn't count. But if you took those two, the overestimate and underestimate, and averaged them, you might get a pretty good estimate of the area. Did you actually do that?
Mm-hmm.
Really? Wow, that's a lot of work. Hats off to you for that. So what did you get?
I got 1.62 to 1.52. Sorry, I said 1.57.
Okay, and so if you average those two, you get 1.57. Turns out what am I